let's explore the concept of specific heat by doing these problems. Now, each of those problems is going to ask how much heat you need to heat certain things up, and you're going to use this equation in each of those cases. So let's talk about what each letter means in this equation, and then what they all mean together. So Q represents heat, and that's how much heat you're going to need to heat something up. And the units for heat are going to be joules. M is the mass, that's how much stuff you're going to be heating up. And the units you're going to have for mass are grams. The triangle in that triangle T is an uppercase Greek letter delta, so that's really read delta T. And that means the change in temperature. So the T is standing for temperature, and that triangle, the uppercase Greek letter delta, is standing for change. So that's really the final temperature minus the initial temperature. And the temperature is going to be in degrees Celsius. SH stands for the specific heat. The specific heat tells you how hard it is to heat something up. So for example, it's easier to heat a metal fork up than it is to heat water up. Different materials heat up either more easily or more difficultly. So if you have a bigger specific heat, it's harder to heat something up, and if you have a lower specific heat, it's easier to heat something up. The units for specific heat are going to be joules per gram degrees Celsius. What this means altogether, on the left, we're trying to figure out how much heat we need to heat something up. That's going to depend on three things. It's going to depend on how much stuff we're heating up, it's going to depend on how hot we want to get it, and it also depends on what the material is we're heating up. Is it a metal or is it water? Alright, the first question says how many joules are needed to heat 500 grams of water, that's about how much water is in a water bottle, from 25 degrees Celsius, so that's room temperature, to 104 degrees Celsius, which is about the temperature in a hot car. Now, anytime they ask you how much heat you need to heat something up, write out the heat equation. Q equals M times delta T times SH. Then, underneath that, write each of the variables separately, so that as you read through the problem, you can organize the numbers you come across. Okay, now it says how many joules. That is heat. Joules are the units for heat. So we can fill that in. That's what we're going to be solving for. Are needed to heat 500 grams. Grams are the unit for mass, so we can plug that in. Of water from 25 degrees Celsius to 104 degrees Celsius. Now those are temperatures, and if you remember, delta T is the change in temperature. It's the final temperature minus the initial temperature. Now, here, 25 degrees Celsius is where we're starting from, 25 degrees Celsius, so that's the initial temperature. And 104 degrees Celsius is the final temperature. That's where we're ending up. We're going to 104 degrees Celsius. So we're going to put the final temperature minus the initial temperature, so 104 minus 25, and that will give us 79 degrees Celsius for delta T. Now that's the last number they give us in the problem, but we still need to know the specific heat, SH. And we're going to get that based on the material it is. The specific heat tells you how easy it is to heat a certain material up. What material are we using here? Water. And so we want to use the specific heat for water. It's good to have the specific heat for water memorized. It's 4.184 joules per gram degrees Celsius. Okay, now that we have each of our variables, each of our letters, we can plug it into the equation. First, I just want to make sure the units match. So for specific heat, I have joules, and that's what we're going to get for Q. For mass, I have grams, and that's the unit in the specific heat. And finally, the temperature's in degrees Celsius, and that's what's in specific heat. So all the units match, so I can just plug the numbers into the equation. So Q is going to equal 500 times 79 times 4.184. If you plug all of that into a calculator and press enter, you will get 165,268 joules. And that is how many joules you'd need to heat up the water in a water bottle from room temperature to 104 degrees Celsius, about the temperature in a hot car. This says how many kilojoules are needed to heat 0.0625 grams of copper from 25 degrees Celsius to 1085 degrees Celsius. Now, this is the 0.0625 grams, that's the mass of a penny, and 25 degrees Celsius is room temperature, and 1085 degrees Celsius is the temperature at which copper melts. That's what a penny is made out of. So really, what this question is asking you is how much heat do you need to make the copper in a penny melt? Okay, every time they ask you how much you need to heat something up, write out the heat equation. Q equals m times delta T times SH. And then underneath that, write each variable individually, so that as you read through the problem, when you come across a number, you can organize the numbers that you run across. So the question says how many kilojoules? Kilojoules is a unit for heat. So we're going to plug that in for Q. Q is what we're going to be looking for, and we're looking for it in kilojoules. Are needed to heat 0.0625 grams. That is the unit for mass. So we can plug 0.0625 grams in for mass of copper from 25 degrees Celsius to 1085 degrees Celsius. So those are our temperatures, right? Delta T equals T final minus T initial. Now here the final temperature is 1085, and the initial temperature is 25. So delta T is 1085 minus 25 is 1060 degrees Celsius. They don't give us the specific heat for copper, but they do give us the material we're heating up, right? The specific heat tells you how easy it is to heat a certain material up. It only depends on the material. So here they tell us it's copper, and this is one you would want to look up in a table. You'd go to a table of specific heats, you'd look for copper, and you'd see that it would give you 0.385 joules per gram degrees Celsius. That's the specific heat for copper. Now, the units that we want for heat, kilojoules, are not the units in the specific heat, which are joules. So we're going to have to do a conversion after we plug everything into this equation. But all of the other units match. Grams for mass with grams in specific heat, degrees Celsius for delta T in degrees Celsius in specific heat. So we can plug these numbers in. Q is going to equal 0.0625 times 1060 times 0.385. Now and the units we're going to get out again from this are going to be in joules, so we'll have to do a conversion. So if you plug that in a calculator and press enter, you're going to get 25.51 joules. We want kilojoules, so we have to do a conversion. Every time you do a conversion, you need a conversion factor that relates the two units. So how do joules and kilojoules relate? Well, there are 1,000 joules in every 1 kilojoule. Okay, so once we have our conversion factor, we can take the number we start with, that's 25.51 joules. Every time you do a conversion, you write a multiplication sign, you write a fraction bar, and the units on top that you start with go on the bottom of the fraction so that they'll cancel out. And we're going to fill that fraction in with our conversion factor. So next to joules is going to go 1,000. Going over the fraction bar is like going across the equal sign, and on top you'll have 1 kilojoule. Joules will cancel out. We're going to be left with kilojoules, and if you plug this in a calculator, it would be 25.51 times 1, enter, divided by 1,000, enter. You should get 0.02551 kilojoules. And that's how much heat you would need to take a penny at room temperature and melt it. The next question says, how many calories are lost when 10 grams of water, that's about how much is in a single ice cube, cools from 25 degrees Celsius, that's room temperature, to 0 degrees Celsius, that's freezing. So how much heat is released when you freeze an ice cube? Anytime they ask you how much heat you're getting from something, write out the heat equation. So Q equals m times delta T times SH. And then write each of those letters separately underneath, so that as you run across numbers in the problem, you can organize them. So the question says, how many calories? Calories is a unit for heat. So we're going to plug that in. Those are going to be the units for Q. Are lost when 10 grams of water, so those 10 grams, that's a mass, gram is the unit for mass of water, cools from 25 degrees Celsius to 0 degrees Celsius. So these are temperatures. Now remember, delta T equals T final minus T initial. And here, the initial temperature is 25 degrees Celsius. That's where you're starting. You're coming from that, and you're going to the final temperature, which is 0 degrees Celsius. So delta T is T final, so 0, minus T initial, which is 25. So delta T is going to be negative 25 degrees Celsius. Finally, the specific heat. They don't give us a number for that, but they do tell us that we're dealing with water. And the specific heat for water you'd want to have memorized, it's 4.184 joules per gram degrees Celsius. Now, let's take a look at the units. The calories here do not match the joules that are in specific heat. That means that we're going to have to do a conversion after we plug things in. We're going to plug these numbers into this equation. The units we're going to get out for energy are joules, and we'll have to convert that to calories. But the grams match with the grams, and the degrees Celsius in delta T match with the degrees Celsius in specific heat. So the rest of the units match, and we can plug them in to the equation, the numbers into the equation. So Q is going to equal 10 times negative 25 times 4.184. If you plug all that into a calculator and hit enter, you'll get negative 1046. And remember, the units out of that are coming from the units for specific heat, and they're joules. Now we want the units in the heat units to be calories, so we have to do a conversion. Every time you do a conversion, you need a conversion factor that relates the two units. So how do joules and calories relate? Well, there are 4.184 joules in every 1 calorie. A good conversion factor to have memorized. Once you have a conversion factor, you can take the number you start with, so negative 1046 joules. Every time you do a conversion, write a multiplication sign, write a fraction bar, and the units on top go on the bottom, so they'll cancel out. Then you fill that fraction in with your conversion factor. So next to joules is going to go 4.184, going over the fraction bars like going across the equal sign, and on top you'll have 1 calorie. Joules cancel, you're left with calories, and if you plug this in a calculator, it would be negative 1046 times 1, hit enter, divided by 4.184, hit enter, you'll get negative 250 calories, and that's how much heat you would need, that would be released when you freeze water to make 1 ice cube. How many kilocalories are needed to heat 5,500 grams of water? That's how many grams of water are in a 6-quart pot of water. So if you imagine a pot that you could fit 6 quarts in, that's about 6 jars of spaghetti sauce. If you're going to heat that up to make spaghetti, and you're going to take it from room temperature to 100 degrees Celsius, which is the boiling point for water, how much heat do you need to do that? That's what this question is asking. So whenever they ask about how much heat you need for something, write down the heat equation. Q equals M times delta T times SH. And then write each of those variables separately so that as you read through the problem, when you hit a number, you can organize it. So it says how many kilocalories? Kilocalories are a unit for heat. And so we'll write that unit next to Q. That's what they're asking for. Are needed to heat 5,500 grams. That's a mass of water from 25 degrees Celsius to 100 degrees Celsius. So those are temperatures. Now remember, delta T is T final minus T initial. And here, T initial is 25 degrees Celsius, and T final is 100 degrees Celsius. So delta T will be T final, 100 degrees Celsius, minus T initial, which is 25 degrees Celsius. So that's 75 degrees Celsius for delta T. Now they don't give us any other numbers. So for example, they don't give us the specific heat. But remember, the specific heat tells us about the material we're using. How easy or hard is it to heat this specific material up? And they give us the material in the problem. They say that we're heating up water. So what's the specific heat for water? It's 4.184 joules per gram degree Celsius. Now let's take a look at the units. First, note they want Q in kilocalories, but in the specific heat for water that we know, it has joules. So we're going to have to do a conversion after we plug these numbers into the heat equation. but otherwise the units match. Grams for mass matches grams in the specific heat. Degrees Celsius in delta T matches degrees Celsius in the specific heat. So we'll plug these numbers in, and then we'll convert joules to kilocalories. So Q is going to equal 5,500 times 75 times 4.184. If you plug all that into a calculator and press enter, you should get 1,725,900 joules. So 1,725,900 joules. Now, they wanted the heat in kilocalories. We have it in joules, so we need to do a conversion. Every time you do a conversion, you need a conversion factor that relates the two units. Now, I don't have a conversion factor that relates joules to kilocalories directly, but I do know how joules and calories relate. There are 4.184 joules in every 1 calorie. And then I can see a relationship between calories and kilocalories. There are 1,000 calories in every 1 kilocalorie. So we can use this first conversion factor to go from joules to calories, and the second one to go from calories to kilocalories. So once you have your conversion factors, take the number that you start with. Here it's 1,725,900. Every time you do a conversion, write a multiplication sign, fraction bar, units on the top go on the bottoms because you want them to cancel out. And then you fill that fraction in with your conversion factor. So next to joules is going to go 4.184. Going over the fraction bar is like going across the equal sign, and on top you'll have 1 calorie. Joules cancel out, we're left with calories, but we want kilocalories. So we have to do another conversion. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units on top go on the bottoms, so they'll cancel out. Then you fill that fraction in with your conversion factor. Next to calories will go 1,000. Going over the fraction bar is like going across the equal sign, and on top you have 1 kilocalorie. Calories cancel out, we're left with kilocalories, which is exactly what we want. And when you plug this into a calculator, you'd put 1,725,900 times 1, enter, divided by 4.184, enter, times 1, enter, divided by 1,000, enter. You should get 412.5 kilocalories. That's how much heat you need to heat up that gigantic pot of water for your spaghetti. Now, this one says, how many kilocalories are needed to heat a huge number of grams, 5 times 10 to the 18th grams of water, from 25 degrees Celsius, which is room temperature, to 100 degrees Celsius? So what is this talking about? This is really the situation that an ancient lake was in. Around 22,000 years ago, there was a lake called Lake Minchin in Bolivia, and it all got evaporated away to form what is now called the Salar de Uyuni. So, in Bolivia, there was this lake, and it was a saltwater lake. When you evaporate salt water, the water evaporates, and you're left with just the salt. This is how people make sea salt. They take seawater, and they just evaporate the water. You're left with the salt. When that happens in a dish, it looks like this. When it happens to an entire lake, it looks like this. This is the Salar de Uyuni in Bolivia. It's an evaporated lake bed, and it can be very beautiful when it rains. So, they're saying, that lake evaporated away. How much heat did you need to do that? Well, every time you're looking for an amount of heat, use the heat equation. Q equals m times delta T times SH. And then write each of those variables separately so that as you read through the problem, you can organize the numbers you come across. So the question says, how many kilocalories? That is a unit for heat. So we're looking for Q in kilocalories. Are needed to heat 5 times 10 to the 18th grams. Grams is a unit for mass, so I'll plug that in for M. Of water from 25 degrees Celsius to 100 degrees Celsius. These are the temperatures. Now remember, delta T is T final minus T initial. The final temperature here is 100 degrees Celsius, and the initial is 25. So the delta T is going to be T final minus T initial, 100 minus 25, and that's going to be 75 degrees Celsius. They don't give us the specific heat, but they do tell us we're working with water, and we've got it memorized. The specific heat for water is 4.184 joules per gram degree Celsius. Let's take a quick look at the units. Note that the kilocalories that they want do not match the units for energy in the specific heat. So we're going to have to do conversions after we plug this in. But the other units do match, the grams for mass and grams in the specific heat, degrees Celsius for delta T, and degrees Celsius in the specific heat. So we'll plug all this into this equation. We're going to get our heat in joules, and we're going to have to convert that to kilojoules. So plugging it all in, Q equals 5 times 10 to the 18th times 75 times 4.184. If you plug that into a calculator, and make sure you put the whole thing, 5 times 10 to the 18th, inside parentheses. If you plug that into a calculator, you should get 1.569 times 10 to the 21st joules. Now, the question wanted the answer in kilocalories, so we need to do some conversions. Every time you do a conversion, you want to get conversion factors. Now, I don't know a conversion factor that relates joules and kilocalories directly, but I do know a conversion factor that relates joules and calories. There are 4.184 joules in every 1 calorie, and then I can see a connection between calories and kilocalories. There are 1,000 calories in every 1 kilocalorie. So I can use this first conversion to go from joules to calories, and the second one to go from calories to kilocalories. Once you have your conversions, you take the number that you start with, so 1.569 times 10 to the 21st joules. Every time you do a conversion, you write a multiplication sign, you write a fraction bar, and the units that you start with on top go on the bottom, so they'll cancel out. Then you fill in that fraction with your conversion factor. Next to joules go 4.184. Going over the fraction signs like going across the equal sign, and going on top, you'd write 1 calorie. Joules cancel, you're left with calories, but you want kilocalories, so you get to do another conversion. Every time you do a conversion, write a multiplication sign, write a fraction bar, and the units on top go on the bottom, so they'll cancel out. Fill that fraction in with your conversion factor, so next to calories is going to go 1,000. Going over the fraction bar is like going across the equal sign, and on top, you'd have 1 kilocalorie. Calories cancel out, you're left with kilocalories, which is exactly what you want. And plugging this in a calculator, you'd put in parentheses 1.569 times 10 to the 21st, so then close the parentheses, times 1, enter, divided by 4.184, enter, times 1, enter, divided by 1,000, enter, and you should get 3.75 times 10 to the 17th kilocalories. That's how much heat was needed to boil away Lake Minchin to create the Salar de Uyuni in Bolivia. Thank you for your attention.